Mike Peterson. I'm a condensed matter theorist here in the physics department at Cal State University Long Beach. I'm investigating situations where electrons become so strongly entangled they form new particles called anyons. And these anyons can form a whole new state of matter, which is pretty cool. I just said a lot in a couple sentences, so let me slow down and explain what I'm actually doing. At this point, it would be hard to show you what I'm doing because it's mostly a lot of mathematics and theory. But I think I can show you a few things to make it a little more approachable. So, electrons become strongly entangled to form a new particle. What does that mean? Well, you're familiar with electrons. They're the negatively charged particles that surround atomic nuclei. They can be added, they can be removed. They run through the power lines above our houses. But most importantly, they act like independent particles. Here's a bottle of water. If you could see the molecules inside here, they'd be moving around pretty much randomly. Some fast and some slow, some changing speed and direction. But under just the right conditions, the water molecules can be made to cooperate with one another and a vortex forms. The properties of the vortex are different from the water we started with. The water molecules have been made to cooperate in a way and become entangled. We think, under just the right conditions, that it's possible to make electrons cooperate in a special new way. These electrons will be so strongly entangled that they'll lose their identities as individuals, and they'll form a big glob, and out of this glob can emerge a new type of particle called an anyon. Now, I should be clear, I'm not actually making anyons. My experimentalist colleagues will do that in the laboratory. What I do is I try to predict, using theory, the ideal conditions under which anyons form. For example, right now, I'm looking at situations where electrons are placed between two sheets, like marbles between two sheets of glass. And I can vary the number of electrons, and I can vary the types of surfaces, and the temperature, and other such things, trying to find ideal conditions where anyons form. So how do I do it? With computers. I write computer programs to test my theories. They're too mathematically difficult to solve with pencil and paper. But a special branch of math called topology can help us understand the complicated way that entangled electrons cooperate to form anyons. Topology is a branch of mathematics concerned with surfaces. This is a sheet. I can transform this sheet into a ball, changing its topology. I can poke a hole in the ball to form a torus or a donut, changing its topology again. In fact, the number of holes in an object is a topological property. The ball has none, and the donut has one. I could further poke two more holes in this, making a pretzel, changing the topology again. This is all very abstract, but in my research, a system of independent electrons and a system of strongly entangled electrons that support the formation of anyons would have different topologies. It's like the boring one is like a ball, and the interesting one is like a torus, it has a hole in it. And this topological property can allow physicists to tell the difference between the boring one and the interesting ones. Of course, I'm not investigating dough, or even simple surfaces like donuts and balls. Instead, I'm using topology and theoretical physics to search for the ideal conditions where anyons can form. And unfortunately, this is not something I can explain in just a few minutes. Most of the interesting problems in physics today are not simple, which is why I like them. I like math, and maybe you do too. I love the possibility of making new types of particles and all the interesting consequences that would flow from this. It's not for everybody. But I'm very fortunate to work here at Cal State University Long Beach, where I can share my passion for physics with students and colleagues and work on all kinds of interesting problems. Maybe you too would like to come and study physics at Cal State University Long Beach.